Hello everyone, for this video we're going to talk about relations, and what a relation is it's just whenever x and y are relating to each other. In this first question we have this right here. You see these curly braces? Curly braces mean that this is a set. And what's inside that set is ordered pairs. So then here we have a set of ordered pairs. And every ordered pairs are the x's and y's together. So you have an x paired with a y, that's an ordered pair. And whenever you have a list of them, you write them with commas and the curly braces around them. So if that's a set of ordered pairs, then we can separate those ordered pairs into a table. If we do it into a table, then we're going to take the left one, and that's going to be the x, -1. The next left one is 1, next one is 2, next one is 3. We're going to do the same thing with the y's. We have -1 as the first y, we have 1 as the second y, 1 and 2. So if we translate the set of ordered pairs to a table, we're just separating the x's and the y's. To go from a table to a graph, we just take the x and we graph the x first, so we're going to go left 1, and then we're going to go down 1. The first dot was at -1, -1. The next dot is at 1, 1, so 1 to the right and 1 up. Next dot is 2 to the right, 1 up. Next dot, 3 to the right, 2 up. So that's how you would express the relation there as a graph. The next thing the question wants us to do is to do it as a mapping. What a mapping is I remember it because it looks like eggs. We're going to draw 2 eggs, and one of those eggs is going to hold all of the x's, and the other egg is going to hold all of the y's. And we're going to just take the x's from the table and put them in one egg, and the y's from the table and put them in the other egg. But when you put these numbers in here, if it happens more than once, like the number 1 happens twice, you only have to write it in the egg once. So in our x's, we have -1, 1, 2, 3. For the y's, we have -1, 1, and 2. Then, this isn't all you have to do. This will be about half of it. After you have the x's and the y's in their mappings, then we have to draw an arrow from the x to the y that it goes with. So -1 becomes -1. 1 for x goes with 1 for y. 2 for x also goes with 1 for y. And 3 for x pairs with 2 for y. It's not until you do the arrow from the x to the y that it becomes a mapping diagram. When we're determining the domain and the range, the domain are the x's and the range are the y's. So if we're going to do the domain and the range, then what's that asking is we're going to label domain, and it's going to be every x that has a y for an answer. So the domain is, we're going to do a set. So we're going to put the curly braces, and inside of that set is going to be pretty much the same thing from the mapping diagram. Mapping diagrams are most useful for identifying the domain and the range of a function or of a relation. Functions are later this week. So to do the curly brace, you do an S and then a backwards S, and the y's have -1, 1, and 2. And we're done with that question. I'll do one more, and I'm not going to do the graph, and I'm not going to do the table. The only thing I'm going to do is the mapping diagram and the domain and the range. So we have an egg for the x's, an egg for the y's. We're going to put each x into one, and you want to do least to greatest. Least, greatest. So the smallest x is -4, then -2, then 0, and then 4. The smallest y is -4, then 0, then 3, and then 4. And then we do the mapping from those. So -4 goes with -4. -2 goes to 3. 0 matches with 4. And 4 matches with 0. There's our mapping diagram. From that, you make your domain and range set. An S, then backwards S. The first one was -4, -2, 0, 4. Since we're on the right side now, you do a backwards S, then a regular S. Range, S, backwards S, -4, 0, 3, 4, doop, boop. There we go, domain and range. The range are just the y's, and in this class, or at least in Algebra 1, in this class, the y's are going to be the same thing as the range at the start. Eventually, I'll just go ahead and tell you right now. The actual definition for domain and range, domain is really the set of x's that the graph of a relation can use as an input. There are some x's that a graph couldn't use for an input, and then if it can't be used as an input, then it's not going to be in the domain. Then for the range, the actual definition for the range is the set of y's that the graph of a relation can use as an output. Quick example for that. Not using this number 3, not using that number 3, if you have a graph, and this graph starts at 0, and then it was a straight line going up from there. Then for the domain, you see how that's a straight line and there's an arrow at the end of that? That means that there's going to be infinite x's. There's going to be infinite x's. But the smallest x is what goes first in the domain. So you go from least to greatest. The smallest x, the most left that this graph goes is 0. And then all the other numbers are going to be bigger than 0. They're going to be bigger than or equal to 0. Every x is going to be bigger than or equal to 0. And then the x's can get as big as possible, but they will never get to infinity. They'll get close to infinity, but they won't reach infinity. For the range, the graph starts where? The graph starts, which means the smallest y is 0, and you can be equal to 0 here. And the largest y, the y's will never be bigger than infinity. The y's are going to keep going up and to the right. Up means increasing y up until you get close to infinity, and to the right means it increases the x until it gets close to infinity. We're going to be doing things like this later. We do it this way. But right now, do it this way. Sorry for the messy handwriting. That's on the corner of my screen. For the independent and the dependent variables, those are the same things as x and y. So they want you to label the x and the y. Independent means that it's going to be the input. Dependent means that it's going to be the output. Independent means that it is the cause. Dependent means that it is the effect. So all four of these things, because we have x, we have independent, we have the cause, we have the input, all four of those things are just different ways to say the same thing. But it asks us to identify the independent. So in this question for number 4, we're going to find out which one of these things happens independently, which means it causes something else to happen. It says the more hours this person works, the larger her paycheck. Does her hours affect her paycheck, or does her paycheck determine her hours? Well, everybody already knows that if you're going to work at a job, you get to choose how many hours you go to, because you could just not show up for work and then they'll give you a tiny little paycheck. So since the hours cause, the hours are the independent are the hours worked. The dependent then will be the paycheck. Increasing the price of an item decreases the amount of people willing to buy it. Do you think that if you raise the price of something, that would be the cause of less people wanting to buy it? If you increase the price, would that cause the effect of less people wanting to buy your product? Or if less people want to buy your stuff, would you raise the price? If people don't want to buy your item, would you raise the price of it? The answer is no. So that means the price causes the effect for how many people want to buy it. So the price is the independent. And the dependent is number of customers. Well, the people who are going to buy your stuff. And there we go.